Okay, so hello everyone. I'm Dániel Szoboszlay, and this is not the first time I'm giving a talk at CodeBeam, but this time it will be quite different from the usual thing I do. It will not be very technical deep dive. And the reason for that is that last year I left Klarna, and with that I left 15 years of having Erlang developer as my day job behind. Now I'm with a company called Erlang and happen to work in Go. So this one will be mostly my reflections on what did I learn from switching to a new tech stack and becoming a newcomer to some piece of technology after a very long time again. And very important disclaimer to put out first. Yep. And this will be pretty much an opinion piece, meaning that I will use big words like this is good, that is bad, this is important, that's irrelevant. But please always keep in mind that these are only my opinion. I will reflect here, and even though most of these questions could be studied, I guess, with scientific methods, and you could collect hard evidence, I didn't do that. The best I have is some anecdotal evidence, but let's hope it will be still interesting for you this way. The other thing is the angle of the talk. I didn't want to do a Go versus Erlang talk, but this was something that I couldn't really completely get out of the topic. So let's face the elephant in the room first and go to the inevitable Go versus Erlang section. So even before starting as a Go developer, I had some expectations on what would I miss from Erlang. Like processes, obviously. Go has also green threads, but they are not the same. They don't have identity, you can't link to them, you can't monitor them, it's just not the same. I knew I would miss Erlang's processes. Pattern matching, very powerful, love it. Gen statums, my go-to tool for solving all kinds of problems, and of course, immutability. But now, 1 year later, I can come back and say, what are the things I really miss from Erlang? The number one is stack traces. You wouldn't expect that, do you? It's not that Go doesn't have stack traces. It does. I don't know what happened with my screen. Let's hope I didn't touch them. Came back. Okay, but they are used in a very different way. So my example will be here starting a web server with a corrupted certificate file. If you do this with Go, you get back this nice error message. It's quite informative. It says right there that failed to find any PAM data in certificate input. Great, but look at the source. It points to my main function. That's not the point where the error originates from. It's the point where I logged it. Because error objects in Go don't have a stack trace attached to them. No matter how much we laugh at Java's wall of text stack traces, to be honest, when I'm about to debug problems in my own code, this kind of error is much more useful pinpointing what went wrong than what Go gives to me. So I miss Erlang's stack traces because we all know that Erlang found the absolute sweet spot between being informative enough but not overly verbose, right? But not in this scenario, because Erlang doesn't produce any error messages if you start it with a bad certificate. So one can say this was not the best example to go with. I say, let's give 1 point to Mr. Murphy and move on. We all know how Erlang stack traces look like. Next thing I miss is Mac. In Go, you don't have hot code loading, and therefore you cannot change at runtime the implementation of functions. What you have instead is interfaces. And interfaces are a quite nice tool for polymorphism. Like if you would like to support 2 payment providers, Stripe and PayPal, it would make sense to have a payment interface in your code so the rest of the application won't have to care about this. But in Go, even if you only want to support a single one, like Stripe, you still define a Stripe interface, which is implemented by the Stripe client and the Stripe client mock, or because you want to unit test the rest of your applications without doing actual payments. And the follows from this is that if you look at a typical struct in Go, it will contain gazillion fields like this, pointers to various interfaces, not because you would have multiple HTTP clients or multiple database connection implementations, but just because you want to swap out these to mocks during unit tests. It's crazy. Mac is much, much better. I miss it. Third one is the shell. The shell is a nice tool for debugging, but especially as a newcomer, you find it very useful for trying out small snippets. You don't have a shell in Go. The best you have is an online sandbox, which is nice, but not the same. Then I also miss project layout conventions, and this one deserves some explanation, I guess. Let's have a look at an open source Go project. This is the Prometheus client, contains 61 files, scattered through a bunch of directories. And if you are a newcomer to this, where do you start reading this? You have no idea. Am I going to the API directory or the Prometheus directory? I don't know. It doesn't help that in Go, every directory is a package. So when you encounter something like Prometheus.register, you know that this should be implemented in a file within the Prometheus directory, but which one? Go figure out. Compare this to what we have in Erlang. This is the React core, 105 files, all in the source directory. Is it any better? I say yes, because of the conventions. So first of all, I know that React core, so first of all, I know that every file implements a single module, so it's much easier to figure out where the implementation of some piece of code is. And then I also know by convention that the public API of this application will be the React core module. The React core app will be the entry point for the application, and that will start the top-level supervisor in React core soup. And from there, I can very easily figure out the supervision tree of this application, and in a couple of minutes, put about 40 modules into some logical hierarchy in my mind. So it helps me a lot to get started understanding what's in this new project to me. And finally, I also miss not having to bother by pass-by value and pass-by reference distinctions. It's just unnecessary brain load for me to know that, will I have to modify this argument? Do I have to deep copy it so I don't accidentally mess up its nested fields? I miss Erlang. But okay, let's compare my original expectations with actual facts. Do I miss processes? Nope. Pattern matching? Nope. Gens data? Nope. And immutability? Sort of, because this pass-by value, pass-by referencing is the consequence of not having immutable data in Go. So it looks quite strange, does it? But let's look at the other side of the coin. I was also expecting some things to gain from using Go, like stellar tooling, because everybody knows that Erlang is lagging behind and Google is at the forefront of things, so tooling must be much better over there. Also, probably some new ways to deal with concurrency. Concurrency is an important feature of Go, so they should be able to teach me something about it. Batteries included libraries, and something unexpected, because things really has to be so good over there that I can't even imagine. You may say that I was a bit too optimistic about Go, but what is the mindset to go into exploring some new territory, if not that? Let's compare this with my realizations 1 year later. What is the #1 thing I like about Go? Basic but functional documentation. This is how it looks like. It's a package.go.dev, and you can go there and find documentation for absolutely any package you would ever encounter. It's not the best documentation, just look at this client set. Client set contains the clients for groups. Set the Zen master and the programmer got enlightened, I guess, but it doesn't matter. What really matters, it's very easy to discover things here. They have this search bar that can search both for packages and within package documentations. A huge win if you are a newcomer, because then you only have some very abstract ideas like, I have a YAML file and I would like to unmarshal data from it. It's enough keywords to get started and find the package that would do that for you. What do we have on the BEAM side? We have hex docs. And to be honest, hex docs are much less friendly to newcomers. This search box here can only search for package names, not within the packages. You don't have an ID integration. And by that I mean that if you hover over a symbol, you will get a tooltip describing that symbol, but no link to a hex docs page. And you can't go and explore from that tooltip. You need to go to the web page for that and see what other things are there in that package. Also, there's a lot of different formats, because edoc and mix just generate widely different looking stuff. It's a minor UX issue, but I think this is the kind of thing that can make or break a tool for newcomers, these small differences. And it cannot be your number one go-to place for every documentation because it doesn't include the OTP apps. And also it doesn't include documentation for like 10% of the packages that you have in Hex. And not just the long tail, 3 out of the top 10 packages don't have Hex docs documentation. That's crazy. On the other hand, I must say that existing docs, in my opinion, tend to be much higher quality. So that's a great thing. Great. Next thing I miss is that I learned is the defer statement. It's a very small syntax trick. Let's illustrate it with this. If you open a file in Go, you immediately can go and defer file.close and then process the file. What it means is just before this function would return, you would call file.close. Semantically, it's the same thing as a try after block in Erlang. The big win, why I like it, is it keeps the open and the close calls visually close to each other in the file. And also it doesn't open a new level of nesting. So if this function would do 2, 3 more things that would have to be undone at the end, then you wouldn't start indenting like crazy. Next is the context concept. So this is what it looks like. If you have, for example, a REST handler that has to do a database transaction with 4 operations, begin, select, insert, commit, then all 4 of these can take some significant time. So you, in Erlang, add some timeout to them, like 5 seconds. The Go way of doing is that in the beginning, you create a context object, set a timeout on that, like 15 seconds, and pass that to all of these calls. And the effect is that the timeout will be for basically the entire processing of the REST request, not the individual steps. And this is much closer to how would you normally expect things to work. Nobody cares about how long it takes to begin the transaction. What it matters is that everything gets done in 10 seconds or 15. And the Go context can do a couple of other things, like it acts as a key value store for putting there things you want to log, for example. And you can also cancel it at arbitrary times. So, for example, if the web server would detect that the client dropped the TCP connection, you can just cancel the context. And no matter how far you are in the processing, you will be able to stop it. So it's a nice trick. I like it. And finally, I like struct tags, which are these green things in Go. So after, when you declare a struct, you can add some key value metadata to fields, which can be queried via the Reflection API. And it's very heavily used for parsers and formatters. So for example, the JSON library here will pull the name of the JSON fields from these tags to know how to encode this data. But you can also use it for like validation and say that this last field has to be something that looks like an email. I like this, and to be honest, I would like to see more of these reflection-based libraries in Erlang too, because in Erlang, reflection is piece of cake. You can very easily go and deconstruct or build up complex data structures. You can inspect what's in a module, do function calls by just knowing the name of the things. It's easy peasy. We don't have this language extension with the tags, and it would be a lot of work, I guess, to add it to Erlang. But you can try to approximate it by some types and abusing types a bit. So it would be fun to write something like that, I guess. Okay, how did my original expectations line up against my reflections hereafter? Stellar tooling? Nope. And I have to say that, in my opinion at least, Erlang's tooling is on the same level as Go. So big kudos to everyone who was working on tooling, be it Rebar 3, ELP, Erlang LS, Dialyzer, whatever. You made an awesome job. New ways to deal with concurrency? No. Batteries included libraries. This is actually true. So if you want to integrate with random software as a service solution, you will probably find in Go a library that does that, but it's not just the API wrappers for you. It also includes connection pooling, load balancing, rate limiting, caching, and whatnot. In Erlang, these things are available, but you have to put them together from puzzle pieces on your own. And something unexpected, not really. You can say defer, and the context were unexpected things for me, but they are not really the big surprises I was looking for. Okay. So if you want to go beyond the language wars level, then what could we learn from this? What could we learn from how to make Erlang more attractive to people, more approachable for newcomers? For me, the number one takeaway was that my original expectations were totally wrong. I have very bad instincts on what would be important for me. And I will go further one step and put out this very bold and provocative statement and say that big language design choices actually matter very little. Yes, Erlang has a nice actor model, it's beautiful, it's coupled well with immutability and let it crash philosophy, and I love it and I expect it to miss it. And I'm pretty sure that it would give Erlang a competitive edge over Go if you would push the systems to the limit. But most of the times, you don't push the systems to the limit. It's like buying sneakers. I don't care about which shoe gives the competitive edge to the top athlete, because I will use those sneakers to walk around in the city streets only. It doesn't matter for me. And also, I think there are no objectively bad languages. I mean, there were, but they are now extinct. Whatever we use has to be good for something at least. And if it has good ideas in it, then it will be most probably ported to other technologies. Let's think about all the supervisor libraries that were clearly inspired by Erlang in other languages. Are they inferior? Yes. Do they work? Also yes. What matters, I think, for projects is supporting a target ecosystem. Like Avrock, we didn't pick at Avrock Go because Go would be the best language, but because we want to do Kubernetes stuff, and everything Kubernetes is already written in Go, so you go with Go. Same with the browser and JavaScript, or if you don't want to do database access, then you pick SQL, and that's it. And for individual developers, I think convenience matters the most. At least that's what I had to realize after listing all these things. And that involves also tooling, but it's also kind of a magnifying glass that can focus on some language or library design particularities, and if they happen to be inconvenient, then magnify them to big problems. And one thing especially relevant for us, for newcomers, the ecosystem discoverability is very important. Can I figure out what libraries are there? Can I figure out easily what can they do, how they are organized, what's in them? And if I look at Erlang through these lenses, then I think we stand pretty good on the individual developer level, the convenience ones. We have good tooling. We have a very discoverable language, thanks to the shell. We have a very discoverable project structure, thanks to OTP. We, in my opinion, have a low-hanging fruit in improving the documentation. Just bring everything together into a single place where it's cross-referenced, have a uniform format, and I think that would help newcomers a lot. But we could also probably benefit from having more batteries included applications to help teams get productive faster. But beyond that, my feeling is that most of the improvements we do, and think about things like what will be in the next OTP release, they are the kind of changes that are like remodeling your kitchen. They can give you, the homeowner, like 10 times life improvement in your kitchen if you have a new one. But for the external world, the property value of your apartment won't go up tenfold. If you want to get that kind of increase, then I think the way forward would be to find a domain that is popular and make Erlang so good fit for that nothing else compares. And what that domain is an open question. For example, I believe for Elixir it is Phoenix, which is a web server and web framework that is awesome and you want to use it, and then obviously then the first-class citizen there is Elixir, so you go with that. So we can imagine some framework like that, or we can imagine a broader domain like telecom or IoT or medical applications, I don't know. The point is that you have to make Erlang such a good fit for that nobody else compares. And yeah, I don't know what will be that. But I think it would be a very exciting quest to go and figure and find out. Unfortunately, personally, I can't promise to get involved in that. because nowadays all my available time for engineering is spent on Everrock's mission of building sovereign European cloud, this one in particular pictured here, which I think is also a very exciting, technically challenging project, even if it's in Go. And also, given the current political climate, also socially very important. But that's something to discuss in the breaks instead. If I have some time left, then I'm happy to take questions about the talk here. That's it. Thank you.
Oh, do we have any questions in the room? I can ask about the location of this picture.
Yeah, this one will be in Arlanda. So the place where you turn from the E4 down to the airport. There you can see, but it's not yet there, so we will start building it, I think, end of the summer or something like that. The next building that's already there, that's not our building.
Anyone? I could have another one. Do you recommend having a change? Is it fun?
Yeah, it's fun. I think not necessarily a language change, but change to a very different kind of work, where you meet new people, meet new technologies, meet new requirements and constraints and solutions. That can be very interesting. Yes, so I'm pretty much enjoying my time at Everrock, even though I really like the Erlang and BEAM world, and I would like to keep connected to this community as well. But it has benefits to sometimes move out from your corner of the world, definitely.
Yeah, I fully agree. So thank you.